Welcome to 6.4's Math Moment. Today students continue to work with volume with different fractions and decimals. So let's take a look at the first example. It says find the volume and write the expression. Well, we know that length times width times height is our expression or our formula for finding volume. So then we're going to analyze our figure and we see that the length, the width, and the height are all there for us. So we just need to line those up within the formula. So the length is how long the shape is. So that's going to be 1/2. Then how wide something or how thick it is 3/4 in this example. And then how tall it is, the height would be 2/3. So I'm just going to take one at a time. I'm going to do 1/2 times 3/4 first. So I would just do top times top. 1 times 3 is 3. Bottom times bottom, 2 times 4 is 8. And then I get to drop down my other side. So I have then 3/8 times 2/3. I'm going to again do top times top and bottom times bottom. 3 times 2 equals 6, and 8 times 3 equals 24. Now, if your student has not or does not realize or remember that they do need to reduce their fractions, this is a great time to also review that. So when we're looking at 6/24, I notice first that those are both even. So remember that there is a trick called the cake method that we taught back in Unit 3 and also in 5th grade to help them reduce fractions. When I'm thinking about 6 and 24, I want to think about a factor that they have in common. If your student just sees a 2, then they could start with a 2. 2 times what gives me 6? That would be 3. 2 times what gives me 24? 24 chopped in half is 12. And then I would keep going. 3 and 12, what do they have in common? And I'm going to work my way down until they do not have any factors in common other than 1. So 3 and 12, when I count by 3s, 3, 6, 9, 12, I can get there. So I'm going to pull out a 3. 3 times what gives me 3? That would be 1. 3 times what gives me 12? That would be 4. So I know that when I see 1 and another number in the bottom layer, I know that I'm finished because there's nothing else that I can pull out of a 1 except a 1. So I would decide that 1/4 is equivalent to 6/24, and that's as low as it can go. Now some students might just like to look at it as 6 divided by something and 24 divided by something, and maybe they see 6 right away instead of breaking it down this way. That's okay too. So our best answer is 1/4 feet cubed. All right. The next example says just find the volume. It's a word problem, so we're going to have to really focus in on what each different side is worth. So it says a rectangular container has a base. Now the word base sometimes can get confusing to students because base means bottom, the bottom of a shape. Well, the bottom of a shape holds, when I use this as an example, if this is the bottom of my shape, the bottom of my shape has the length and the width. Okay, the height comes then with the top of the shape. But when I think about the base, then it should give me the numbers for the length and the width. When we're multiplying, the order doesn't really matter. I could have multiplied these two first and then taken it by 1/2. We would have got the same answer. So the order doesn't really matter. So if they can't quite figure out exactly which one is the length and which one is the width, that's okay. So then I see that it says 1 5/10 inches by 3 inches, and then I also have 2 75/100 inches in the height. So again, I have all 3 dimensions because the base gives me 2 numbers, and then my height gives me my third. So I'm going to go ahead and put this into my formula, length times width times height, and I'm going to set it up as 1 5/10 times 3 times 2 75/100. Now, I'm going to go ahead and just take my first 2 numbers and multiply them. I'm going to do it over here, just so we have some space. And we encourage students just to ignore that decimal at first when they're multiplying and multiply just as if they were whole numbers. So 3 times 5 is 15. 3 times 1 is 3, plus 1 is 4. There's 1 number behind the decimal in this problem, so I want 1 number behind the decimal in my answer for a final answer of 4 5/10. but then I need to go ahead and bring down my 2 75/100 times 4 5/10. So I'm going to set it up just like I would a regular multiplication problem and solve across. 5 times 5 is 25. 5 times 7 is 35, plus 2 is 37. 5 times 2 is 10, plus 3 is 13. I'm done with my 5, so I exit out and anything that I carried over with it, and then I add a placeholder. 4 times 5 is 20. 4 times 7 is 28, plus 2 is 30. 4 times 2 is 8, plus 3 is 11. So then I just get to add this up, and I know it's getting towards the bottom of the screen there, so I will pull this up for you to be able to see. But the number that I got when I added everything up and multiplied were the digits 1, 2, 3, 7, and 5. Now when I look back at my problem, I had 1, 2, 3 total numbers behind the decimal. So I want there to be 1, 2, 3 total numbers behind the decimal in my answer for a final answer of 12 375 thousandths. I'm working in inches, and then I cube my answer since I am finding the volume. If you have any other questions about this unit, make sure to see your math teacher.